Welcome to AI News Digest 2026-0604. Today's 12 stories. Story 1, LLM Updates, June 2026, AI Model Releases and Provider Tracker. Story 2, Toward Pre-Deployment Assurance for Enterprise AI Agents, Ontology-Grounded Simulation and Trust Certification. Story 3, The Digital Apprentice, a Framework for Human-Directed Agentic AI Development. Story 4, StepPRM-RTL, Stepwise Process Reward Guided LLM Fine-Tuning for Enhanced RTL Synthesis. Story 5, Not All Errors Are Equal, Consequence-Aware Reasoning Compute Allocation. Story 6, Can Generalist Agents Automate Data Curation? Story 7, Stumbling into AI Emotional Dependence, How Routine AI Interactions Reshape Human Connection. Story 8, SMAC-Talk, a natural language extension of the StarCraft multi-agent challenge for large language models. Story 9, Exploring cross-scenario generality of agentic memory systems, diagnostics, and a strong baseline. Story 10, The Saturation Trap, Why Affect-Based Triggers and LLM Judges Fail to Time Interventions on Autonomous Agents. Story 11, WSJ AI News, Foxconn-Intel AI Partnership Meta Model Delay, AI CEOs on Bioweapons Law. Story 12, VAMPS, Visual-Assisted Mathematical Problem-Solving Benchmark. Researchers studying autonomous AI agents have uncovered a fundamental problem that threatens one of the field's most important safety assumptions: the idea that we can reliably detect when an AI agent needs to be interrupted. A new paper from Archive, titled The Saturation Trap, exposes critical failures across every major class of intervention trigger currently being studied for agentic AI systems. The research by Manvendra Module uses an 18-dimensional effective dynamics engine called HART to probe how agents behave during long-horizon software debugging tasks drawn from the SWE benchmark. The team tested 4 types of intervention triggers: simple threshold detectors, composite state action pattern detectors, regex-based reasoning extractors, and LLM-based judges, all evaluated against human-annotated intervention points. The first major finding is what the paper calls the state saturation trap. When an agent encounters sustained difficulty, its modeled frustration score rapidly hits its maximum value and simply stays there. This means threshold-based triggers, which fire when an agent seems distressed, end up firing on between 39 and 83% of all actions. Instead of detecting specific moments of crisis, they become a near-constant alarm, making them essentially useless as precise safety tools. The second finding concerns LLM judges. Smaller models, like a mini version of GPT, never fire at all. Larger frontier models only start working when given the full conversation history, and even then, they achieve F1 scores of just 0.17 to 0.4, at up to 90 times the computational cost of simpler methods. That is an extremely poor trade-off. But perhaps the most striking finding is about the human annotations used to train and evaluate these systems. 3 trained annotators, all using the same rubric, agreed on where to intervene at only barely above chance levels, a Krippendorff's alpha of just 0.047 for location. On intervention type, agreement was even worse, falling below chance for some categories. What this means is that the ground truth the field is optimizing toward may not actually exist as a stable, reproducible signal. If humans cannot reliably agree on when an agent should be interrupted, then training or benchmarking a system against those labels is measuring noise rather than safety. This paper doesn't offer a solution, but it provides a critical and comprehensive map of the problem, one that the entire agentic AI safety community will need to grapple with seriously. The Wall Street Journal's AI coverage is highlighting 3 stories that together capture the current state of the artificial intelligence industry in mid-2026. A landscape defined by massive infrastructure investments, competitive pressures on model releases, and growing concerns about catastrophic risks. First, Foxconn and Intel have announced a partnership focused on AI infrastructure. This is a significant pairing. Foxconn is the world's largest electronics contract manufacturer, known for assembling iPhones and countless other devices. Intel, meanwhile, has been working hard to reclaim relevance in the AI chip market after years of losing ground to NVIDIA. By combining their strengths, these 2 companies are signaling their intent to compete for a slice of the booming AI data center market. Whether this partnership can meaningfully challenge the current GPU-dominated infrastructure paradigm remains to be seen, but it represents a serious bet on alternative AI compute pathways. Second, Meta is again delaying the release of a new AI model to developers. This is notable because Meta has positioned artificial intelligence as absolutely central to its future, yet the company keeps running into timeline issues with its model releases. The delay could reflect technical challenges in hitting performance targets, slower than expected safety evaluations, or a calculated decision to avoid releasing a model that might look weak next to competitors from OpenAI, Google, or Anthropic. Whatever the reason, repeated delays are not a great look for a company trying to establish itself as a top-tier AI player. Third, and perhaps most consequentially, top AI company CEOs are calling for legislation specifically targeting AI-enabled biological weapons development. This is remarkable because AI leaders typically push back against regulation. The fact that they are proactively asking for legal guardrails in the bioweapons space signals that the industry itself views this as a risk serious enough to warrant external constraints. Biological weapons represent one of the most frequently cited catastrophic AI risk scenarios, and legislative action here, if it moves forward, could set important precedents for how governments regulate AI and other high-stakes domains. Taken together, these three stories illustrate just how rapidly the AI industry is evolving across technology, competition, and governance dimensions simultaneously. A new benchmark called VAMPS, which stands for Visual Assisted Mathematical Problem Solving, is exposing a surprisingly stubborn limitation in today's most capable AI models. They cannot effectively use graphs as thinking tools, even when graphs would clearly help. The benchmark was created by a team of researchers from multiple universities, including UBC and UCSD, and it contains 1,168 multiple-choice math problems drawn from Iranian university entrance exams covering algebra and calculus. What makes VAMPS distinctive is that every problem in the dataset was specifically chosen because plotting the relevant functions would reveal the answer naturally, by showing intersections of curves, extreme values, or asymptotes. These are exactly the cases where a student or engineer would reach for graphing software. The researchers then tested a range of multimodal large language models in two ways. First, by having them solve the problems using only analytical reasoning, and second, by giving them the ability to generate graphs and use those visualizations to ground their answers. The expectation would be that tool-enabled visual solving would do better. After all, the problems were designed for this approach. But the opposite turned out to be true. Direct analytical solving consistently outperformed the tool-enabled approach across all models tested. This finding points to a meaningful gap in how current AI systems handle multi-step tool use. It's not enough for a model to be able to read a graph or execute code that generates one. The model also needs to know when generating a graph is useful, produce a graph that captures the relevant features, and then correctly translate what it sees in that graph back into a mathematical answer. That full pipeline is apparently breaking down somewhere, and that breakdown matters a lot for real-world applications. In science, engineering, data analysis, and countless other fields, visualization is not just decorative, it is a core reasoning strategy. If AI assistants cannot reliably leverage visual tools even when those tools are the obvious approach, their practical utility in these domains remains limited. VAMPS gives the research community a clear, focused diagnostic to track progress on closing this gap. StepPRM-RTL combines stepwise trajectory modeling, process reward modeling, PRM, and retrieval-augmented fine-tuning to improve LLM-based hardware design code generation in Verilog and VHDL. The framework targets long-horizon reasoning with strict correctness constraints, a domain where LLMs have historically struggled. This paper challenges the assumption that all reasoning failures are equally costly, proposing consequence-aware compute allocation for test-time reasoning. Rather than spending thinking tokens purely based on predicted difficulty, the framework allocates compute based on the downstream consequences of errors. The paper introduces Curation Bench, a new benchmark testing whether generalist coding agents can automate the iterative data curation loop in AI development. The benchmark fixes the model and training recipe while giving agents command line access to propose, implement, and evaluate data policies. This paper challenges the assumption that AI emotional dependence arises only from deliberate use of companion chatbots, arguing instead that it commonly emerges incidentally from ordinary task-oriented interactions. The authors draw on empirical evidence to show how routine AI use can reshape human emotional and social behavior. SMAC-Talk extends the StarCraft multi-agent challenge benchmark to evaluate LLM-based agents in cooperative multi-agent environments, requiring natural language communication and coordination under uncertainty. This addresses the growing need to benchmark LLMs for collaborative agentic tasks rather than isolated performance. This paper systematically evaluates 8 LLM agent memory systems across 5 diverse scenarios to assess whether existing designs generalize beyond the single scenario they were tuned for. The authors find most systems fail to generalize and propose a strong baseline that performs more robustly across heterogeneous agent trajectories. This paper studies the problem of when to interrupt autonomous AI agents during long-horizon task execution, finding that affect-based triggers and LLM's judge approaches both fail due to a saturation trap. The work evaluates 4 intervention trigger families and exposes fundamental limitations in current runtime safety layers. The WSJ AI section highlights 3 significant stories: Foxconn and Intel teaming up on AI infrastructure, Meta continuing to delay its new AI model release to developers, and top AI CEOs calling for legislation protecting against AI-enabled biological weapons development. VAMPS is a new benchmark targeting a specific weakness in multimodal LLMs: performance degradation when models must externalize a problem through a visualization tool and then reason over that tool's output. The benchmark mirrors real engineering and scientific workflows that rely on visual aids.